Hello friends, myself R.D. Mahajan presenting my video on Gauss Elimination method. Method to solve linear simultaneous equation. Let us consider three simultaneous equation in three unknowns as a11x1 plus a12x2 plus a13x3 is equals to a14, first equation. Second equation is a21x1 plus a22x2 plus a23x3 is equals to a24, and the third a31x1 plus a32x2 plus a33x3 is equal to a34. There are three equations in three unknowns. Unknowns are x1, x2, x3, which we have to determine by Gauss elimination method. And to determine it, we have to perform two stages of elimination. In first stage of elimination, where to eliminate x1 from equation 2 and equation 3. x1 from equations 2 and 3. To eliminate x1 from equation 2, perform where to multiply this equation 1 by the ratio a21 by a11 and then subtract it from equation 2, that is equation 2 minus that multiplying factor is a21 by a11 into first equation. To eliminate x1 from equation 3, by performing for that we have to multiply this equation 1 by the ratio of a31 by a11 and then subtracting it from equation 3, that is nothing but equation 3 minus multiplying factor is a31 by a11 and into equation 1. When we perform these two steps, this x1 is eliminated from equation 2 and equation 3, thereby getting a new system of equation. Therefore, that new system of equation is at the end of first stage of elimination. We have a new system of equation as first equation no change as it is. Second equation is converted to fourth equation where x1 is eliminated, and we have the new values for that coefficient as a221 means the first approximation for a22 into x2. A231 means first approximation of a23 into x3 is equals to a241 first approximation for a24, and equation third is converted to equation fifth as 0x1, x1 is eliminated, a321 x2, a331 x3 is equals to a341. That 1 in bracket means the first approximation or the new value for that coefficient. And therefore, in second stage of elimination, we have to eliminate this x2 from equation 5th. In second stage of elimination, we have to eliminate x2 from fifth equation by performing the following step. To eliminate it, we take the help of equation 4th, which we have to multiply by the multiplying factor a32 divided by a22, and then subtracting it from equation 5th. And therefore, that step is equation 5th minus multiplying factor is a32 1 divided by a22 1 into equation number 4th. When we perform this step, this x2 is eliminated. We get new system of equation. And therefore, that new system of equation is first equation no change as it is. We get a11 x1 plus a12 x2 plus a13 x3 is equals to a14. First equation as it is, no change. Equation 4 remains as it is, that is a22 1 x2 a23 1 x3 is equals to a24. We call this as equation 4th. And instead of equation 5, we have new equation as x2 is eliminated. We get a new value for a33 as a33 second approximation for it into x3 is equal to a34, a new value for it, and we call this equation number 6. Here it is 0 plus 0 plus, and therefore if you observe the system of equation, here the lower diagonal elements are 0, means we get upper triangular system of equation. We get upper triangular system of equations. Therefore, here the first part is completed, where I have converted the lower diagonal elements to 0, or I have eliminated x1 in the first stage and x2 in the second stage. And after getting this type of upper triangular system of equation, we can obtain the values of x3 from 6th. By back substituting it here, we can find the value of x2, and substituting these two values in the first, we get the value of x1. By back substitution procedure, from equation 6, we get the value of x3 as a342 divided by a33 we get the value of x3. Using this in equation 4, using it in equation 4, we get 8 to 4 1 minus transferring it to right hand side, we get 8 to 3 1 into x3, whatever the value of x3 we put here, and subtract this 2 to get the value of x2. Using these two values, in equation 1, we get the value of x1 as this is 8 to 2 x2 is equals to, therefore we have to divide by 8 to 2 divided by 8 to 2. Okay, here we get a11 x1 is equals to, means x1 is equals to, we have to divide by a11, therefore it is 1 by a11 into a14 minus, transferring this to right hand side, we get a12 x2 and minus a13 x3. So by back subtraction, we get the values of x3, x2 and x1. This complete process is called as the Gauss Elimination method. This complete process is called as Gauss Elimination method. I have explained this with 3 equations in 3 unknowns. We can extend it for any number of equations. 4 equations in 4 unknowns, 5 equations in 5 unknowns, or n equations in n unknowns. Remember one point, if we have 3 equations, there are 2 stages of elimination. If we have 4 equations, there are 3 stages of elimination. If there are 5 equations, there are 4 stages of eliminations. My next video, we solve one example by Gauss Elimination method. If you like my video, please subscribe to my channel to receive or to get a notification for my new videos. Thank you very much.